It's being recorded.
Thanks.
No. Thanks to you. I try to set up to be recorded automatically, but it seems it's not possible. So thanks for reminding me that. Okay. So as we stopped in the previous class, we had our small assignment here, right? We have our code. The code is divided into the index, which is doing nothing besides loading the the graphic library, right? And starting our script. It's inside our script where we have our small piece of code, right? This is the to-do things that you have to do. We have here our setup that we know it's the beginning of the function. We have our draw. We have a couple of secondary functions. I'm gonna call these secondary functions. Secondary function. Is that okay? And the same way than this one, okay? The same way than this one, okay? So what is happening to do here? Well, the first thing that I was trying to do is changing the timbre of the sound. So we were saying if the ball hits one of the walls, then we are gonna change the sound. And I was giving you a small hint here, which is play a sound, okay? Now let's modify the function to have two input parameters, okay? And then another hint that was happening here is that you have to split the cases from the left and right, and also split the cases from the top and bottom. Basically, what I want you to do? Basically, what I want you to do is divide this, okay? If you are you following the class? If you have any question or I have to go back a little bit, just let me know. Please speak as much as you need.
Could you do the screen bigger?
Could I do what, pardon me?
The screen bigger because
Oh, the screen here. Yes, I think I can do it. Just give me 1 second. Give me just 1 second. I have to stop, and then I guess I have to change to be this one. Yes. Can you see better now? Yes.
Yes, it's
Yes.
fine, teacher.
Perfect. Okay. So what I'm doing is just because now in our previous case, in the previous thing that we were doing, we were just checking if it's bouncing in the left or the right at the same time, or the top and the bottom at the same time. Now we want to have different behaviors on each one of the cases. So I have to split this because we cannot keep it as a or here. Remember, this is an or, and we were doing if it's hitting the left or the right. But now we have to split it, so we have to basically just doing if it's hitting one area, okay, or it's hitting the this other area, right? You follow what I'm doing? I'm just explaining a little bit. I just split this into two different sections, and I will do the same here, okay? So I'm gonna split this to be top and bottom, we're together, and now I'm gonna do bottom and top in a different location. Does that make sense? Any
Yes.
question in this part?
No, teacher.
Okay, so to do split the cases, that's it. Done. With this to do is done, and this to do is done, right? Now we want to differentiate, and we want to use the same play as sound. I saw that some of you decide to create this function many times. Basically, some of you did this. You copy this, and then you say play a sound case 2, and then this is play a sound case 1. Do you follow what I'm doing? And then you have 4 functions that are actually do pretty much the same. Okay, that's did anybody, Diana, why are you laughing?
No, not teacher, because I think pensé hacer eso,
Okay.
pero mejor no.
Okay, and then, but that is that is a little bit fishy, to say it in a fancy way. It's not, when you realize that you are repeating behaviors, probably there is a more elegant way for doing it. Okay, so basically what I'm gonna do is, when I'm gonna set a second parameter to the function, and this will be called, how do you want to call it? For example, location. It can be location. It can be called, no matter how, right? We can call it as with any name that we want this variable, but we will keep it like that. So with that, we are done with the play a sound. Okay, and now the little detail that we have to do is this one, just an if case for the four numbers. So in that particular case, now our four functions, this will be, for example, a 0, a 1, a 2, and a 3. For example, it could be a number. A number is more succinct, it's more clear for many of us, but you could also try to do it with a string. For example, you can say if it's a left, right? No, this is not left. This is top, right? This could be the top, and this could be the bottom, and this could be the left, right? And this could be the right. Does that make sense? You can do it by letters, but for me, it's more elegant to do it by numbers. Okay, if I do it by numbers, then I have a 0, 1, 2, 3. Okay, as simple as that. Therefore, in this case, the only thing that I need to do, it's an if statement. If, right? If location it's equal to 0, right? Then what should I do? Well, I play it as a sinusoidal, right? And I accidentally remove this one, which is the just an if case. So we are done with this. Use the second parameter for so this is the part of the assignment. So we can do this, and then I can do else, right? And then I say if location it's equal to 1, then this is so, I think so, right? Else if location is equal to 2, we can saw it as I think it's triangle, right? Triangle. Please let me know if this is fine or not. And at the very end,
You need to put the complete sawtooth.
pardon me?
In the saw, I think you need to put the complete sawtooth. Sawtooth.
Oh, it's not saw, it's do I have sine, saw, triangle, and square?
Square.
Square like that? No, it's
No, he means that it didn't work with saw. It needs to be right sawtooth. Like
so how do I web audio API, and then oscillator, right? And then I go here to the oscillator node, and then in the oscillator node, I have the different types. Okay, sine, square, sawtooth. That's what you mean, right? And then this one has to be sawtooth, and then the other one has to be a square like this. That makes sense, right? And that's it. So this is the tuning part. And then at the very end, the only thing that we are missing for the assignment. So this is already the thing that we were doing here. That's it all set. And finally, what else do we need to do? Write an envelope, not yet. Modification, try to do the modification that you want. Modification to this is, and the DB challenge, we will talk about this in a few seconds. Okay, so the only thing that we are missing now is the envelope, right? So each time that a node is heated, that is when this is happening here, each time that a node is heated, we want it to start with a volume of 0. So basically, we want here to say set volume of 0, set value at time when immediately, right now, please start with a volume of 0, right? And now, how can we make an envelope? There is a better, I mean, I know that some of you try to do it with a complex library, set of libraries, but there is a very small and simple way for doing it.
What I did is like to declare two variables, one for the decay and one for the attack, and then sum, that's just gonna be in seconds. So and then sum this onto the current on the start for the attack on the stop of the decay.
Yes, but how do you make it a transition? Because if you set a value, you will jump from one point and then you will change it in the future. So that means
I multiply it by, I did with an exponential. I multiply by the number e. So you can have a smooth transition.
But is it working? Are you actually listening how the volume is increasing and how the volume is decreasing?
Just a little bit. I don't hear the clicks anymore because there was some clicks from the stop and the starting, and now the clicks are not.
But are you using a different parameter than set value at time?
No.
No. Okay. Let's go to the documentation, right? And here at the documentation, I will go to any audio node or any, for example, to the yes, to the any audio node. Let me go here and then we go to where can you see that? If we go here to an audio node, okay, or a frequency, okay, and I'm going in an frequency, it says the frequency property of the oscillator node interface is an average audio parameter, okay? This is an audio parameter. So you have a way for doing this as a set value at time, right? But at the same time, you can also do something else. For example, let's go to an audio parameter, right? And you can have like set value at time. Can you see this? But you also have linear rhyme to value at time, okay? Or set value curve at time, or things like that, cancel and hold at time. And the one that we want to use is actually this one, okay? We can use a linear rhyme to value at time, okay? Schedules a gradual linear change. This is important. I don't know if you managed to do it or not, Emerson, but this is a gradual linear change in the value. The change starts at the time specified for the previous event, follows a linear rhyme to the new value given in the value parameter, and reaches the new value at the time given in the end time, okay? So this one is important, okay? This is now the end time. When do you want to finish? So basically what we need to do is a linear value here, okay? So we start at 0. Then we want to set this gain again, right? This part that we have here is the gain, right? This is what it's saying. Envelope 2 lines of code. This was the to-do part, okay? We want to go to a value of 0.2, for example. I don't want to go to 0.1. It will be too loud, okay? 0.2. And when do we want to reach the 0.2? That's up to you. But what about if we do it in a half of a second, okay? So we do it in the present plus half of a second, okay? And then this is kept in memory. That's why it says here, this is important. The change starts at the time specified for the previous event, okay? The previous event is this one. Actually, this is the one that is held in memory. And then we want to go and says, now please, okay, go again to 0, go again to 0 in which amount of time? Well, the half of a second that it took to go up, and then let's say another half of a second to go down, okay? So what's happening here? Well, what we are saying here is that, can you see my drawings, my pink drawings?
Yes.
Okay, so
Yes,
this
teacher.
is time, this is the time, this is well, this is the time, okay? So at some point in the process, we click, oh, the ball bounces the wall in the second, I don't know, in the second fourth. This is 0 is when the application starts, okay? Here's when the application starts. 4 seconds later, okay, the ball hits the wall. That means that the audio current time is 4. So we are saying right now at second 4, set up the volume to 0. This is volume 0 and this is volume 0.2. So at this point, we set the volume in 0, okay? Immediately, this is 0, right on, okay? And at that point, we say, please create a linear ramp, okay, to reach 0.4 in, right now, what time is it? 4 seconds plus 0.5. So please go to 0.2 and reach that position at second 4, because that's the current time, plus 0.5, that means 4.5, okay? And then that is the previous, that is a specific moment in time. And then we go to the second element, to this third line, and we say, create a new linear ramp, go to 0, we will go to 0, starting when? In the previous event, which is this one, that means starting in 4.5. And when do you want to finish? Well, I want to finish in the present, which is 4, plus 0.5 plus 0.5, that means on second 5. On second 5, that's it on second 5, please go from the value that you have at that moment, which is 0.2, starting in 0.2, please go to 0 and end up in 0 when you reach the 5, okay? In that way, you create something that increases over time and decreases over time. Does that make sense?
Yes, teacher,
Yes.
but I have a question.
Yes.
I'm sure you already said it, but I don't understand why you put 0.2 in the line 92. Yeah.
Oh, that's the volume. Your volume can go from 0, you are not gonna hear anything, and you can go to 1 if you want it as loud as possible.
Oh, okay.
Remember that a digital signal, 1 is your maximum value, would be extremely loud, okay? So I just select 0.2 because I know that I have big speakers, and if I put 1, I'm gonna have an issue with the volumes in my speakers, right? So I decide to put 0.2, but you are right. You can say this to be volume, right? And we can set this to be volume, volume to be whatever, right? Anything.
Okay.
Any value between 0 and 1, right? Well, 0 would be nothing, would be silent, right?
Yeah.
I have a question also, teacher.
Thank you.
Yeah, the audio context dot current time, it's the second when the ball is hits the walls, right?
Yes, this is the moment when the function is evaluated, they play a sound, but the function is evaluated when the ball
When the ball hits the
wall.
any wall, right? Okay, yeah.
Does that
Yeah,
make sense?
because I tried to use that function, but I didn't know how to use it.
I see. Now, how can you, to be honest, sometimes I get some complaints because I do not explain anything. Sometimes I do not explain the things to the students, but I'm pretty sure that if you Google web audio API envelope, right, whatever is going to happen, you're going to end up with explanations about that. For example, I hear there is an envelopes and this person is describing exactly what I'm just saying, okay? And if you set it in here, you are gonna set target at time, right? And if you read this, you will see that little by little, you will get it, okay? Exponential ramp to value at time and things like that. So it's part of the assignment to find these situations. It's actually very simple nowadays. Nowadays, because you were born in the internet. I was the last generation that was born without internet. And it was a pretty complex way because you have to go to the library all the time to find a book. So this is pretty simple. Does that make sense?
Teacher,
Yes.
so in that piece of code, every time our circle, our, I don't know, ball hits the corner or something, the volume increase and decrease just in that piece of code of the set, but no, line ramp to value at time. That means that every time the ball hits our volume increase and decrease, like.
Be careful. The volume of that particular ball, because actually this is important to notice, okay?
So if we want to add more balls, we need to do one by one in that ball with line ramp to value time.
No, because if you can, that's a very good question, Fabian. If you realize when the ball hits the wall, right, a new unit generator is created, okay? So this creates a new sound. All this function is creating new sounds. Actually, that's another reason why I set this to 0.2. Let me explain you why. If I decide that this is not going to take 0.5 of a second, but it's going to take let's say 1 second to increase, okay? And then 1 second of the increasing plus 3 seconds of decreasing. In this particular example, if I play it, please let me know if you hear it. Can you hear?
A little bit.
No.
No.
I don't think, let me see. Can you hear now?
Yes.
Well, I don't hear it anymore, but as you can see, we have a couple of sounds happening at the same time, okay? That means that every sound has its own envelope. Every sound has its own envelope, okay? Now, actually, I don't hear, so this is a little bit complex. Let me, how can let me see if I can hear it again. But, well, actually, 1 second is too long, so you don't hear it as part of the hitting, just as a matter of perceptual situation, but this makes a little bit more sense. So, Fabian, each ball has its own sound. Okay?
Yes.
Okay. Well, this was the assignment. Now, the tricky part, okay? The tricky part. I just want to know if I haven't seen the assignment yet. So did anybody of you manage to do multiple balls? Please just raise your hand if you managed to do it. Your blue hand or your physical hand. Okay, Jonathan. Anybody else? Anybody else?
Actually, I just managed to create one more ball, but I did it in a very bad way.
What do you mean
Because
with bad way, Jonathan?
I didn't do it in a clean way.
How do we? Yes.
I just added more variables, and I copy and pasted.
I see. I see. Okay, so if you want to have 50 balls,
Yeah, that's
okay.
that's
I see.
the freaking part.
Okay. Okay, let's go back. Let's go back just a little bit to our previous, to the example that we have here. Okay, I'm just moving to the previous assignment or to the previous, how do you say, piece of code that is in open processing. Do you remember that? Do you remember that before going to the audio, we were working a little bit on this example that is just the graphics, right? So if I understand well, what Jonathan did was basically saying, I'm gonna copy this, right? And then I'm gonna copy this is ball two, right?
Yes.
The second and the second and the second, and then you keep adding and adding code. Okay. Let's go to this amount of notes. I just want to know what is amount notes. Could you remind me? Oh, this is the amount of notes. If it's in the top, okay. Well, could you remind me what an array is in any programming language? One thing is knowing the array. I know that you know what an array is, right? You took your programming classes. You were taught about arrays. You have a notion about arrays. But one thing is like, did anybody here speaks German or French or something like a weird language? Well, not weird actually, but a different language than Spanish or English. Emerson, what do you speak?
Italian.
Italian. Okay. Anybody speaking Chinese? No. No. Well, if we go and took a Chinese class, probably the first year we are gonna be struggle and we will know the grammar and we are gonna start to learn the words, but we are not gonna be able to think in Chinese for a long time, right? Thinking in a programmatical way takes a lot of time, okay? That's why people tend to avoid it in some time. I mean, unless you love it, right? Could be a problematic process of learning. So we know arrays. Can anybody of you explain me what an array is?
Well,
It's a
I find on Google arrays a series of memory locations or boxes, but honestly, I don't remember what an arrays do in programming sessions.
Okay, anybody trying to explain in your own words what an array is?
It's kind of a list. I could put it like that, like a list that can relation the position of any variable inside of a box, if you can say like that. And this box is with an index, is the position of the element that we are looking for inside the array.
Okay, anybody else? Pablo Palomino, what an array is? No?
It's like a set of memory of arrangements. I think it like that of that way.
like a
Okay.
set of many arrangements that you can call it whenever you want.
You're getting closer. Yes, you're getting closer.
It's a bunch of data.
It sounds good also.
Mm, I don't know the truth.
No, it's okay. You're fine. I mean, I'm just trying to be more detailed. How many people is in the class actually? Let me see. How many people is in the class? Oh, 29 students. Because I just see one part of in my screen. I just see half of the group, and then if I change my screen, I see the second group. My son arrives late to his class. He tried to arrive as close to the beginning of the class, so he's in the second part of the page, and then he's not seen by the professor. Can you imagine that? I hope that you are not doing that, but okay. So okay, an array. Yes, arrays are boxes. Let me take advantage of what I have in my studio. Can you see the back of my studio? Okay, I'm gonna stand up. Okay. Okay, I have a box, right? This is my box. And I have my first box. And then I have a second box. And then I have a third box. Okay? Basically, what I'm doing is an array. That three boxes together can be an array. Could you back to, I'm gonna, oh, you can see both of my things, right? My screen and my body, right? Yes.
Yes.
Okay.
Yes, teacher.
So let me create something new here, like how can I create a new one? Let me save this, and then let me go back here, and then let me create a new sketch here, creating a sketch, and then okay, that's it. Okay, what I'm just doing here is saying that I need a box. Okay, so basically what I'm doing is my collection it's equal to an array. Okay, you can see my code, right? Basically, but I have only three boxes. Inside my box one, I have an audio card. This is an audio card. Okay, on my second box I have a cable, and on my third board I have an adapter. Okay, so what I'm doing here is basically saying that I have an audio card, that I have cable, and that I also have an adapter. Okay, basically what I'm doing here is saying I have a collection of boxes. On the first one I do have an audio card, on the second I have a cable, on the third I have an adapter. Some programming languages like Java are really mandatory that you have to have the same kind of objects inside the boxes. If you have numbers, you have pure numbers in all of them. If you have strings, you have strings. If you have colors, you have only colors. JavaScript is not mandatory in that sense, and you can have number, a string, and another array. Okay, for example, but this notion of having a collection of things it is extremely powerful. It is extremely powerful, right? Because I can create also, for example, a set of names, right? And then I can create a collection of names, and then I can have here Fabian, right? And then I can have Jorge David, right? Jorge David. And then I can have Antonio, right? Antonio. And then I can have a Charlie Romero, Antonio, and then I have a Charlie, and so on, right? Now, could you let me know how can I get a specific number from there? How can I get the name of the first person in the list in this particular case?
It's with the index, right?
It's names, what?
brackets and 0.
Brackets and 0, right? Is this something that everybody in this class has as fresh as anything else in this class? Or please,
I have a question.
yes.
This is how you take out the number 0, the position 0 from the array, but this is like a variable, like names bracket 0. It's like using a variable, or you can insert that into a variable.
And could you repeat the question, please? 0 is the location, is the position of this location that is here, is the number, is the index. It's what is called the index, and this will be the 1, and this one will be this 2, and this one will be 3. Okay.
But for example, if we want to use what it's on number 0, Fabian in this case, we only put that as names bracket 0, and that's all.
Yes, name
Okay.
bracket 0 is a way for saying, please go and give me what is inside the first box.
So, teacher, let me know if I'm right. If we have an array and inside of the array we have a lot of sounds, we can take one of sounds and put in some, I don't know, in this example, in some ball that we have in our previous code.
Okay.
Or
yes, let me
or
go.
no.
Let's apply the notion of that in this particular example. Do you remember that here we have sine, sawtooth, triangle, and a square? Yes, do you remember that?
Yes.
Instead of having this as an if case, instead of having this as an if, I could very easily create here a variable that is called kind of sounds. It's equal to, right? And then let me go here to, it was sine, right? And then it was triangle,
triangle and square.
Triangle, which other one?
Sawtooth.
Square like that. And
yes, sawtooth.
So to that, how do you write it? Like this?
Yes, correct.
Yes.
Okay. So could you tell me why or how can we use this in such a way that these become even more more compact?
So instead of sign, we could add 0, the number 0, or no.
Be careful. Remember that location is a variable that is coming from top, bottom, left, or right.
It could be if location it's end of we could put like my little sound dot type equals type of sound brackets location.
Exactly. Good. Instead of having this, I can just say it's gonna be equal to, what's the name of my function, of my array? Kind of sounds. Okay. Kind of sounds, variable, location. Yes. And then we can say bye-bye to all this section. Can you see that?
Yes, Simon.
So why you didn't do it?
Because we didn't know.
But you know what an array is.
Teacher?
Yes.
Do we?
I'm not sure why you typed locations inside kind of sounds.
Oh, okay. Okay. Kind of sounds was defined as an array, right? Kind of sound, it's an array, right? It's not a number. It's not a string. It's an array of strings. You understand that, right? It's a collection,
Yes.
like my
Yes.
boxes that I have in the back, right?
Mhm.
So how can I go and retrieve the square string? How can I go and say, please give me what it's contained on my third location of the array? How can I do that in a certain amount of position in the code? How can I do that?
You type brackets and then it would be 2.
Okay, so
One,
everybody,
no?
pardon me?
Nothing, sorry.
So we know that with brackets and a number inside, what we are actually doing is saying, please give me what it's in the second element, actually not second because it's ordered from 0. So please give me what is on the third element because this is index 0, location 1, location 2, and location 3, right? So basically what we are saying is, please give me what it's in the box with the label number 2, and then we get the square. Yes, does that make sense?
Yes.
So if that is the case, and we know that when we hit the left wall, we are sending a 0. Who was asking why? Okay, and if we hit the right, we are calling the function with the value of 1. If we hit the top, we are calling the function with value of 2. And when we hit the floor, we send or we call the function with a value of 3. So in the case that we hit the bottom, we are sending a 3. So this function, it's evaluated with the number 3 here. Because location has a value of 3 in that particular moment, that means that we are gonna retrieve the location of the array in the position number 3.
Yes. Okay, I can see it now.
Okay.
Mhm.
Okay, so hey guys, this is way more elegant than this, isn't it?
Yes.
Okay.
I could say so.
Yes, it's more compact. So it's important. I'm assuming many things in this class. I'm assuming 2 things: that you already took programming classes, and if you have this kind of questions, you will do 2 things: asking me a lot, stopping me if I'm going too fast, and also doing research during the week in these topics. I'm assuming that 3 things, or those 3 things. Okay, so if that is the case, okay, we have to have that notion of arrays in order to do the next part. So let me go to the previous assignment, leave, and then I want to go to my sketches, my musical interface, which is this one, right? Then I will go back to my code. So what is happening here is, actually, I'm gonna copy all of this function. Or actually, look at this. I'm gonna do a fork. So, oh, Luis did a fork, and Victor Romero did a fork. That's nice. Nice. I'm gonna create another fork from this. I'm creating a fork. A fork is a copy that is a variation. So now I have a new fork. Okay. This is a new piece of code. Okay, that's it. That's it. Okay, now I can modify this one without any problem. Okay, so pay attention to this because probably this is the most important part in the class. We want to have multiple balls, right? So instead of having a location, I'm gonna do the following. How many balls do we want? Let's say 10. Amount of balls are going to be equal to 10. Okay, 10 balls. So instead of having location x, okay, location x, the variable location x, it's going to be equal to an array. Location y is going to be equal to another array. Okay, the size of the sleep, do you want the balls, all of them, to have the different sizes or all the same size?
Different sizes, different sizes.
Different sizes. Okay, so that means that the ellipses are also, it's also going to be an array. The speed, do you want them to have different speeds or the same speeds?
Different speeds.
Different. Okay, so this will be also an array, and the speed of x is going to be equal also. No, actually, sorry, the speed of x and the speed of y, they have to be an array, and the amount of nodes. Oh, this is the octaves, right? This is the thing that was telling us the. Let's forget about this for now, because I want just to go to the little detail here. Let me go very quickly and modify the heating speed x math console play a sound. I'm gonna remove this, and then this location amount wide. This is the node. I'm gonna remove this, and then if I go to this location, y speed mode play a node, and I'm gonna remove this. Okay. Now, in the setup, as you can see, this is something important. In some programming languages, the arrays should be declared with a specific size. I have 3 boxes, and I cannot have more boxes on the fly. Once that I define that I have an array of 3 elements, I cannot change the size. However, on JavaScript, I can at some point says, I want another box. So you just go and you add a new box on my array. Does that make sense? Right?
Yes.
We are going to take advantage of the ability of increasing the arrays, right? We're going to do that. And we're going to start with arrays of 0 boxes. Okay? Now, I'm going to create my canvas. This part that is here, create my canvas, check mark, that is clear. I'm going to set a fill color. That is clear. Oh, do you want the colors of the balls to be the same or different?
Different.
Okay, so we are going to need also the variable colors or color. It's going to be also an array, right? Actually, I'm going to say col. Okay. So because of this, okay, now this is fine. If you have questions, let me know. This is fine. This fill color is fine. And then we need to do, we need to populate or to fill my arrays with values. So how can I iterate, or how can I do something many times in a programming programming code?
With a loop?
With a loop. How is the traditional way for doing loops?
With an iterator and a for.
A for, exactly. So we are going to say for an int, or for a variable I, right? Starting in 0, while I is smaller than the amount of balls, right? I'm going to say I plus plus. Anybody with a question in this section? Anybody with a question?
Just with the I plus plus. Well, it's going to add 1, but that is how I don't understand. Can you explain what's that position?
Okay, actually, this is the same that saying I, it's equal to I plus 1. Okay? This is the real way for writing things. This is the proper way of writing. But for example, when we speak in Spanish, you say, yo voy para la calle. But sometimes we say, voy pa la calle, right? And we just make it shorter. Instead of saying para la calle, we say pa la calle. Well, the way of saying the I plus plus is identical to say I is equal to I plus 1. And I is equal to I plus 1 means my variable, I have a variable that has a value. Let's say that I has the value of 5 in that moment. It's going to be equal to what I have in the moment, in that particular moment, which is 5 plus 1. So what is the value of I after, what is the value of I on line 16?
6.
What?
If it's, pardon me, if I is equal to 5, let me remove this. I shouldn't be doing this. Forget about this. If I is equal to 7, let's say, and then say I is equal to I plus 1, how much is I in this point?
8.
It's 8. If if I is equal to 7, and then I say I is equal to 2, how much is I?
9.
9. Does that make sense? This is just a way for saying whatever you have, add something, right?
Yes,
Well,
teacher.
okay. I have to go slow just in case that you don't get it. Well, this can be translated to actually to saying plus equal 1. This is a shortcut for doing that. Okay. Now, because and you can do plus 10, actually. You can do I, it's equal to I plus 10. This is the same. If I was 9, how much is I at this point?
19.
19. So you have to be familiar that you have this way of saying plus 1. The other shortcut is this one. This is just adding 1, okay? So what we're doing here is saying, I have a variable that is starting in value of 1. This starts with the value 0. Then this is a ternary operator because you have first part, then the second part, and then the third part. Okay, you're saying please do whatever is inside this section of code. Please do this until I it's bigger than this. Or in another way saying, please do it as long as I is minor to these values. Amount of values it's equal to 10. But on each repetition, please increase I plus 1. So I is going to be 0 the first time. Then because 0 is smaller than 10, then do whatever is inside here. When I finish doing this, please increase I plus 1. Now I it's equal to 1. It's not 0 anymore. Now it's 1. Now it's a 1 here. Because 1 is smaller than 10, right? Then do whatever I have here with I equals to 1. And once that I'm done, increase I, which is 1, to become 2. Then the next time, this will be 2. Because 2 is smaller than 10, blah, 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 blah. At some point, I will be increased from 9 to 10. Then I will be equal to 10. Because 10, then are you going to say 10 is smaller than 10? No, at that point, 10 is not smaller than 10. That means that this thing that was always true, this thing that was here, was saying true because 1 is smaller than 10. True because 2 is smaller than 10. True because 3 is smaller than 10. But at some point when I will be 10, is 10 smaller than 10?
No.
No. 10 is not smaller than 10, is equal than 10, then this will be false. Because this will be false, then I break and then I quit this section of code. Whoa, 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 whoa. Oh, give me a second. And then I don't do this anymore. Yes, does that make sense? I think who was asking, Fabian? No.
No, me. Yeah, it's absolutely making sense.
Okay, so what are we gonna do? We are gonna add elements to my arrays. How can I add elements to an array? Well, JavaScript, add elements to an array. How can I do that? With the push function. Actually, you can see it here. My array, banana, orange, apple, and mango. And then you add a kiwi and you run this, try it, and then you add a kiwi, right? You can just go to these examples here all the time, and then you got it. What does that mean? That my location X, okay? My location X, I'm gonna push, okay? I'm gonna push. What am I gonna push? Well, a random position, okay? I'm gonna push a random position. I'm gonna set a random number. And the same is gonna happen in my, in my location Y, right? Basically what I'm doing is copy this. I'm putting that inside here, okay? What am I doing here is that location Y dot push, I'm gonna add a random value, okay? Does that make sense? This is important to understand that now I am generating random numbers. How many random numbers? Actually, I'm generating 10 random numbers. Yes?
Yes.
Okay.
Don't you have to generate first the random number for the size of the ellipse?
Size of the ellipse, yes, you're right, because now size of ellipse is also actually I'm gonna, because now it's not a constant, I'm gonna change it. Okay, size of ellipse, you are completely right. So in the same way, can you tell me what should I do, please?
Size of the ellipse dot push, and between parentheses random random, and it could be between, I don't know, 20 and 40, something like
Okay,
that.
maybe because we're gonna have 10 of them, I would make this smaller, between 10 and 20, for example, right? And then I have to change the size of the ellipse here, and then the size of the ellipse, the size of the ellipse, and the size of the ellipse. Yes, does that make sense?
Absolutely.
Okay, now the color. We also said that we want to have different colors, right? So we have to set random values for the color. For right, okay, okay, let's do that directly. Same idea, color, right? Dot push, and we want random numbers, right? Random numbers for the color. Can we remember how can we do the colors in open processing? I don't remember, so P5GS color, and then reference for P5GS, and then this is a way for saying color, okay? Color, and we can set a variable with different colors, or color by a string, or color by a hexadecimal value, right? Or color by 3 different numbers. It seems that we can have these as different numbers. Yes? Do we have grayscale? I don't think we have grayscale in color. That means that we just need to set yes. If only one value is provided, the color will be interpreted as a gray scale. Okay, so that means that we can do it in the same way here. Color push, a random number, right? a random number between 0 and 255. And this will be a gray color. So we have now the color. Yes? Oh, actually push color. No,
This one, exactly. Color dot.
color.
Color parentheses random and that. No?
Yes, you are right. You are right. So where were we? We were here. Cancel. We were here. Color, parentheses, and that's it. Yes. No questions? Sure.
No.
I don't see many cameras on.
No, teacher.
Everything's okay.
For me, it's safe if I can see you guys because it's I don't know. I feel better. Okay. Okay. So we have color here. Now that's it. Now we have this draw, and I'm gonna comment for now. Just for now, I'm gonna comment from this piece of code from here to here. This is all the changing location, changing whatever. Okay. Now, how many balls do we have to paint? 10 balls.
10.
So instead of painting one ball, we again are gonna use the 4 for painting. We are gonna paint 10 balls, right? 10 balls, which is ellipse. However, this is not a number anymore. This is not a number anymore. And this is not a number anymore, right? These are arrays of numbers. This is not a number, but a collection of numbers. So how can I'm going to change this to become plus plus because it's smaller, right? And let's clarify things. So what should I do? Because now this is not a number. How can I go and retrieve the first iteration, the first element of the array, the second iteration?
With the I, right? Within brackets, we need to put the I.
And we need to put the brackets of everything, right? Yes, does that make sense?
Could you repeat that, teacher, please?
Yes. Okay. So this is a big step. This is a big jump. This is a small step for humanity, but it's a long step for you. No, the other way around. It is you understand what I'm saying, right? This is important. We are expanding because before in our previous example, the variable location 1, X, and location Y were numbers. This was a 5, right? This was a variable that contains a number, and this variable was another thing that was holding a number. Now we decide to have the same name, but they are not numbers anymore, okay? This is not a 5, and this is not a 6. This is a collection of numbers. This is now a collection of numbers. Why it's a collection of numbers? Because we define the variable to be a collection of how many numbers? Well, with 10 numbers. Why 10 numbers? Because we are iterating and we are putting numbers here. So location X was nothing. On the first iteration of these 4, okay, we were adding a random number. So on the first iteration was nothing. Then on the first, we add a random number between, let's say a random number, I don't know, 20. I don't know. It's just a random, I'm just guessing a number. On the next iteration of this, remember that this thing that is happening here is happening 10 times. On the next iteration, we had a 20 and we add a random number. Jonathan, give me a number between, Jonathan, a random number between 0 and 10.
5.
5, okay? Next iteration, we had a 20 and a 5. We had a 20 and a 5. And then we add a random number. Fernanda.
3.
3. On the next iteration, we have a 20 and a 5 and a 3. And then we are adding, right? A new number, a new random number, right? Ángel. Victor. Random number.
16.
16. And you understand the idea. At the end of this, at the end of line 18, we end up with an array with 10 random numbers, 25, 3, 16, 8, 9, 6, and 3. There are 10 numbers in that array, right?
Right.
Okay, now, in this iteration, now, do you remember that the draw function happens a lot of times because it's an animation, right? We have a draw, right? So how can we retrieve and say, please paint a circle on which location? Well, please go and give me the first one first. Please give me the 20. And on the second time that you draw a circle, please go and draw the circle not in 20, but in 5, in location 5. On the third iteration, because this is happening 10 times, go and draw a circle, but now in location number 3. Do you understand? Well, we will say, please give me the location of I, because we know that I is changing because it's a 4 and we have a variable defined. We know that I is something that is increasing, and this will happen 10 times. The first time with I equals 0, I equal 1, I equal 2, I equal 3, because the first time I will be equal to 0, I equal to 0, right? I will go and I will retrieve the first number that is located in the array. Let's say it's a 20, right? The second time I will be equal to 1. Therefore, we will go and retrieve a value that probably is a 30 or whatever. Why? Because we were adding numbers here with the push in this 4. First, we were adding numbers by random. Right? And then now we are going and retrieving. Do you understand this logic?
Yes, thank you, teacher.
Okay, so that's it. Theoretically, but life is always complex and probably we will have mistakes. We do have mistakes. Oh, it says random was expecting number for the first parameter and it received an array instead. Okay, we're having a problem. Oh, yes. Could you please help me to solve the mistake that I created?
You have a size ellipse as a variable instead of an array.
No, the other way around. We have it as an array and it should be a number.
You should take out the first value like we did with the locations, right?
No. Size ellipse is not a number anymore. Size ellipse, it's not a number anymore. It's an array, right?
The array is empty.
Well, no, the array it's growing. It's growing on each different step. Okay. So we do have a value on that particular location. I give you 20 seconds. Please try to guess.
You need to take out that value from the array, right? Oh, she left. Adios.
No. No, I was closing the door. No. Come on, come on. You can do it. You can do it.
Maybe we need to put the variable a. Well,
I, exactly. Exactly. Well, not the, we need to use the variable I as the index. So pay attention to this. Size ellipse, it's an array. It's an empty array. The first time that we do the for loop, size ellipse, and that's why somebody of you said that we have to use the set size first. I don't remember who.
Me.
Who? Emerson. Yes.
Yeah.
So, the first time, okay, we add a random number between 10 and 50. So the first time we add a 9. Now we have a variable, an array with one element. That means that we can use it here and says, please give me the value that I just put there, right? So I will be able to use here, I will be able to retrieve that number, right? I can go and retrieve that specific number, right? Yes, that might make sense. Gustavo, yes? Mariel?
Yes.
Okay.
It's like if you were like choosing a value of the array.
But yeah, but a specific value of the array. You are actually choosing the specific value of the array.
Yeah, in this case, the value in the position 0
of the array,
right?
yes.
Because we are doing this for the first time.
And the first time in the position 0, exactly. And then if we run this, theoretically, now we do have, right? We do have 10 different, right? We do have 10 different circles of 10 different dimensions on 10 different locations. Yes? But all of them are red. All of them have the same color. Why? Because the fill function that is here, the fill function that we have here, right? The fill function that is here is saying, please go and grab a red paint. And each time that you tell me to draw something, I will paint it with red, right? It's like saying, please go and grab the red pencil. And I will be painting with red until somebody tell me to change the color. So what I'm gonna do is, instead of saying, please go and grab the red color at the beginning of my program, okay, I will go here and I said inside the for, please go and grab which color?
Random that we use, no? The color of the array colors, right?
Okay, so call what?
And the iterator, the I again, no? Into brackets.
The I, right? And then we iterate over I. Theoretically, now we do have 10 different balls of 10 different grayscale, right? Yes?
Yes.
If we want to have them with different colors, I just add R, G, and B here, and then we will have 10 different colors here. Okay, so as you can see, the size of the code, if we compare the amount of line of code between the function of 1 and the function of 10, it's the same. Actually, if I decide to have 100, I just have 100. This is what makes programmers rich, because you just code once and you charge for 1 million persons in PayPal, right? As simple as that. That is a little bit scary, right? But as you can see, that's it, right? If you organize your ideas properly, you do this in a very simple way. Now, let's start to move them. What about it? Okay, let's start to move them, and then we have the 10 minutes pause. In the same way now, let's gonna update locations, right? These update locations will be exactly the same. Or actually, we can do all of these if and all of these things here inside our for. So I will move my for. Instead of ending my for here, right? I'm gonna end my for here, right? And all of these that I had as a value will become an element of the array. Yes?
You need to change the size of the ellipse.
Yes,
also.
I will do that in a second. Location, ellipse, location, ellipse, speed of y, speed of x. Oh, we have a problem with our speeds, by the way. And then this node is gone, right? And then we have to change the size sleeves because I decided to change the name of the variable here. Yes. And then I'm just gonna indent properly just for clarity purposes, because I know that this part it's inside my for, right? I'm just indenting. This is not mandatory, but it is very clear that this it's inside my for and that this it's inside my if, just because I'm indenting properly. The computer doesn't matter if I have this here, right? But for me, it's nicer to understand. So theoretically, everything should be fine, except for one reason, except for one thing. This will complain. Could you tell me why is this gonna complain? It didn't work? Could you tell me why it didn't work?
We are not pushing values into the location array, in the speed array, right?
Exactly, because the speed x, and speed y are arrays, empty arrays, and we did not fill them with values, okay? So we are gonna try to go to my box number 5. Can I go to my box number 5 in the back of my orange boxes? What happens if I want to go to a box that doesn't exist?
Yeah.
It's gonna complain. So what about if here we set up our speeds too? So in here, we will do exactly the same that we did in here. So my speed x, y, speed x dot push, and we are gonna push, and then we need to set a random number because we want different speeds, right? Random number between 1 and 2, right? And speed and speed y is going to be a random number again between 1 and 2. So if I run this, now all my balls start to move, right? Does that make sense? Now we have a small detail here because all the balls are starting to bounce with positive values. Therefore, they move backward to the bottom and to the left. We will fix that. But for now, just change the speed of my balls to be a little bit more dramatic. And this is going to be to 5, maybe to 10, and then to 10. And then we run this. And some of them are going to move really fast. And some of them are going to move really slow, right? Okay.
Okay.
What was the problem that you were talking about? I mean, I didn't get it.
The problem of the array?
No, the problem of the bouncing balls, that they are bouncing to the same.
Oh, look
side,
the
right?
balls. If you go here, let me do this. And I run it again. All of them are moving back to the bottom, right? And to the left. Let me do it again. All of them to the bottom and also to the left at the beginning of the code. It would be nice that some of them bounce to the top at the beginning of the code, right? What should we do? Remember, how do you make the ball change? Because the speed is changing. This is something that we were talking about previous class, because they have a negative value. Therefore, some of them should have negative values, right? However, we cannot say go to the -3 or minus random -4 to 4, because then this will generate a random number between -4 and 4, which could lead to have a value near to 0. And if it's near to 0, it's not gonna move. Well, let's say that we don't care about that at this moment. If we decide that some of them are gonna have negative values, then some of them are bouncing to the top at the beginning and some are going to the bottom at the beginning, right? However, we can find maybe some balls that are not moving at all because the speed is extremely slow. So at the end of the break, we are gonna put this now. Oh, we are gonna put this piece of code in our sound environment. Okay. So it's 8:31. See you here at 8:42. Okay. 10-minute break.
Teacher.
Yes.
Sorry, can you share the code, please?
Absolutely. The code is, if you go, let me go here. It's here. I'm gonna put this code. I'm gonna put it on the chat. Oh, I have 43 comments. Oh, sorry, I apologize. I didn't check, but it seems that it's not okay, that's good. No, not
just spam, teacher. Don't worry.
Just spam. Okay. Oh, Japanese. Okay. See you in 8:43. 8:43. Okay.
Okay, thank you, teacher.
Hello. Are you there?
Hello.
Yeah. Because you say that I'm on Twitch, I'm gonna Twitch now.
Yeah. Let's play some Fortnite.
Okay, no. I'm just curious. If I decide to do it in this way, I think the resolution of my screen gets lower. So let me know if that is the case. Okay. So I can say Lapex. Okay. No, here in my family, Minecraft is the thing that is at the peak. I don't know if you play Minecraft at some point or you're still doing it. But here's crazy. My son is crazy with Minecraft. Okay, so let's keep moving. Let's keep doing the next step. Okay. Is everybody here now? Could you turn on your cameras if you don't mind, please? Yes, please turn on your cameras and let me know if you can see my screen in an appropriate size. Okay, let me make this a little bit bigger. Yes, I think you can still see my screen in a proper size. Otherwise, let me know. Okay, we are done with the code. Then we go back to here, okay, and then we want to do the same, okay? How can we port this to the sections that we have here? Because we have a bunch of things that are different, right? So the first thing that I will do here is that all the part that is from the graphics will be moved from here to, okay, I don't know if I can duplicate these.
Teacher, sorry, I think there's something wrong with your camera. We only see in a little box your screen and your camera, but not in the big screen.
Okay, that was my concern. Okay, yeah, so I'm gonna stop playing with these things and then I'm gonna start sharing this in a more advanced way. Is that fine?
Yeah.
Okay, so okay, what is exactly what we want to do? Well, we want to move the code that we did first from the graphics to the sections that we have here, right? The thing here is that all these secondary things, I'm gonna remove this part that is from here that we already have here. And then the play sound, it's okay. The my math is okay. The section that is inside the loop, it's all the section that we have here, right? However, we do have a couple of things that are different. So pay attention because this could be a little bit messy in the amount of screen that in the size of the screen that I will do. Okay, so I'm gonna remove these here that are here. I'm gonna copy the things that are here, right? And then I'm gonna start to just double check the things that I have here. We don't need this anymore, right? However, we do want the diatonic and the kind of sounds here. These two things that are here, they will go again to here, right? The things that are here, what do we have? This is the audio context that is here. We are gonna get the audio context from the start setup. We are gonna put the start setup also here, right? The audio context will happen here, right? And then the setup is gone. Bye-bye. Then the ellipse, the location, we have a small problem in the bouncings, right? As far as I remember, do we have here the bouncings? Yes, just be careful because in the bouncings that we have here, I also have to duplicate, or we also have to duplicate the bouncing here, right? Because in the previous example, we were not concerned about top and bottom, left and right. And in this case, we do concern about top, bottom, left, and right. So I erase the beginning, I erased the end, I erased the end, I erased the beginning. Yes, please let me know if I'm doing something wrong, but according to this should be fine. Okay. which is the part that we have here. Then we have the note diatonic, blah, 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 play a sound. So this piece of code that was here is something that we need to move towards here. However, yeah, the variable diatonic, math, play, truncate, location Y, now it's going to be I, right? Amount of notes, window high, play a sound note. I think this is fine, right? Does that make sense? I think it's fine. This was the first section here, and then this is the second section here. You understand what I'm doing, right?
Yes.
So here I'm just copying this here, and then this should be fine. And then finally, we do this one here, right? We do this one that is here, and we copy this towards here. And this should be also fine, right? Does that make sense? This is X. This X is now I, right? And finally, we copy the last piece of code that we do have here, that is here, and then we copy this towards here, right? And this becomes a I here. And then we can say bye-bye. I hope that you have a code of this because this will be gone. Oh, we do have an error. Okay, yeah, this can go bye-bye. This can go bye-bye. And that's it. And as you can see, I think we are all set. Okay, I think at this point, I'm gonna also remove this as a second parameter. This is gone, and this should be gone. Yes, as far as I can see, everything should be working now. We just have a small detail here that we are not gonna hear anything until we click something, okay? And the problem of clicking something is that all the big sounds, if we don't click the button quickly, all the nested sounds are gonna be preserved, and then it's gonna hear very ugly. So let's check it. Yes, let's check in a new window. Whoa, something happened here. Yeah, big say. Oh, okay. Amount of notes is not defined. As you can see here, we have amount notes is not defined, and then the code complain. So where amount of, why do we have amount of notes? Could you please remind me where were we using amount of notes? Amount notes.
Eran las octavas.
Oh yeah, you're right. Amount notes. Well, amount notes is actually the size of what? Of diatonic, right?
Yes.
So how can we know the length of this array? How can we say, well, we will just want 12. How can we do amount of notes to be 8? Well, we can type 8, right? However, there is a better way for getting the length of this size. So how can we get diatonics? Well, we can say size of array in Java script, and then we say that is just as simple as the property length. Okay, so if it's the property of length, we can go back. Oh, what happened here? We can go back here, and then this is diatonic. Diatonic dot length, and theoretically this should be now fine. Why I don't hear anything? Okay, it says that set value at time on audio parameter provide float value is not finite at play a sound script line, and then we have a problem in line 83. In line 83, frequency set value of MIDI FREQ note audio current time. Is it working for you guys?
It said something about the audio contest that cannot be started.
Yeah, what happened if you click on the balls?
Nothing. The thing stopped.
Fail to execute set value at time on audio parameter. The provided float value is not finite. The provided float value of
For me, it's working.
For you, is working?
Yep.
Yeah, me too.
Is it loud? Maybe it could be extremely loud because at some point it could happen that you have 10 sounds playing at the same time. If you have, no, actually more than 10. So probably this would be better to say it maybe 0.05 or 0. I don't know, 7, or I'm just guessing. This is something that we have to test, divided over the amount of balls, right? Maybe this is gonna be 2, and I'm gonna reduce this just a little bit because first I want to do a test with 10, but amount of balls that we have here. For you is working, but for many of us it's not working. I don't hear anything. Are you hearing on your computer or something?
No, teacher.
Yep.
Some people is actually hearing something, right?
Yes.
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 Can you check? Okay, I don't hear it. Kind of sound, that's fine. Set value at time. Who says yes? The people that says yes, what browser do you have? We are in the same problem that the other.
Chrome.
Opera.
Chrome. Now I can hear it. I think it's something with the Zoom because I can hear it now.
Oh yeah, I do have it with. Yes, it was my yes. Oh, it's fine, but I don't like it. To be honest, I don't like it. It sounds really, really ugly. I don't.
Teacher, how did you solve it?
Oh, it was a mistake in my audio card. For at least for me, the problem was on my audio card.
It's because I have the same code as you, but mine is not sounding at all.
Can you click immediately when you click on your on the screen as soon as you started? Is it working?
Yes, I think so.
Okay, now there are a couple of things that I really don't like. First of all, I don't like the why is it sounding too, I don't oh, I see my problem. And probably you do have the problem too. The envelope is not working properly. I do have something that is increasing the volume, okay? That is increasing the volume in 0.1 for the going up and 3 seconds for the going down. However, I'm stopping the sound at 0.1. When you stop it, you are actually killing that oscillator. So I'm killing the oscillator before in 0.1. So I have time and I have, this is the moment where the sound started, 0.1 for going up and 3 seconds for going down, right? However, I'm killing this at 0.1. So I actually just hearing the going up, but I'm not hearing the going down. So how can I solve that?
Increasing the time of the stop, right?
Yeah, and then at least what?
4 seconds.
Well, it depends. What is
at least the time of the decay, right?
The decay plus the attack, right? At least the time of the attack and the decay, right? So, and now we have something, okay, these are magic numbers. The things that we do have here, these guys that are here are magic numbers. So magic numbers in code are fine for small codes, but when you start to have something of 1,000 lines, could be a little bit problematic. So I'm gonna create here, actually I'm gonna create this to be also a variable, and then I'm gonna create a variable for the attack time. Attack time is gonna take 0.1, and then a variable for the for the decay, okay? And my decay is gonna be of 1 second, okay? So attack time and attack. Do you write attack like this? Attack?
Yes.
Attack and decay. So we have this as attack time, right? So this will be attack time, and then this will be attack time, and then this will be a decay. In that way, I know where should I go if I want this to turn it off. And then I'm just gonna add as 0.001 just to be sure that it's gonna stop before. I mean, this is just for, this is not logic. This is, no, actually not. This is just magic. So there is no magic in this. Okay, that's here. I'm just putting this. This is just a style. You don't need it. So I save, and then it's kind of okay. I don't like it a lot. Maybe just by increasing a little bit the sound, okay? I'm just gonna increase this to be a little bit more. Let's try to see if with 100 our system is gonna work. Okay, this, and then I'm gonna try to do the decay a little bit longer. My decay is gonna be of 3 seconds, and let's see what happened if my computer will manage to do it or not. It's loading. It's kind of okay. But maybe now it's too long, okay? Maybe that's too much. So 3 seconds was too much. I'm gonna do it again of half of a second, okay? Maybe this generates too much noise, so I'm gonna create this to be 50, okay? And let's give it a second try. I don't know. I don't like it a lot. To be honest, I don't like it a lot. but it's explaining many of the things that we were doing. Teacher, copy this, body margin padding, remove top left. Oh, thank you. Okay, so Victor, in the CSS, as you can see here, oh, no, this is not. The other day we were missing the situation about the margin, okay? So as you can see here, the margin of our body has 2 index of this, and then with this we remove the white space. With this we remove the scroll bars, and then with this we remove the blue outline of the canvas. Excellent. So I guess we can remove the body because here we are repeating, and then that's it. Theoretically, this should be fine. Let's see. Nice. Thank you, Victor. Okay, that's it. Now, what about the following? One thing that could happen that could be very nice is
if the balls exploded.
If the what? Oh, yeah. Well, yeah, we can do that. Oh, one thing that could be nice, actually, it's very simple to do, is changing the color of the alpha values. Okay, so we are going to make the color a little bit transparent. So if we add a 4 parameter in the color, okay, I think that we will be able to have transparency. However, we don't want it to have full transparency. So I think if we do this from 100, let's see what, no, not here. Well, we can test it here. And they are a little bit more transparent. Do we want to remove, can you see that they have all a black border? A black border, it's surrounded. Do you like it like that? We can also remove that. So, but let me go to the here. So not to here, to, where were we? Not here. Where is my code? Did I close it?
I think you closed it.
Oh, okay. So it was a glitch. And it was audio game tech, right? Yes, it's this one. So if we go to my index, to my script, and then we are going to do a couple of things. It's this one that is here. We're going to add a transparency element here. Okay, but it's not going to be full transparent. It's going to be only from, let's say, from 200 to 255. Another thing that I want to do here is that I'm going to remove the border, the contour, the black contour. So in addition, in any place in the setup, I'm going to say no stroke. Okay. How do I know about that functions? Well, I know them by heart, but if you go here to P5ES documentation, P5ES documentation, right? You will have all these reference, and here are the different things that you can do. Like, for example, no stroke. With no stroke, you remove the rectangles, okay? So as far as I can see, okay, that's it. Now we don't have strokes, and then we have a small transparency. However, I don't think that is the proper transparency that I want to do. So actually it's the other way around. So it's going to be transparent from 0 to, I don't know, to 80. Let's see what happens if I do this. Oh, they are extremely transparent now. They are too transparent now. Okay, so they are extremely transparent now from 100 to, I don't know, from 100, from, what do you want? From 120 to 100 and to 290, for example, right? Okay, that's it. Now, but no, let's stop about playing with the graphics. This is not a graphical class. We can focus a lot in the graphics, but I don't like one thing about the sound. What can you do in terms of sound?
Maybe add some rhythm to it.
Add some what?
Rhythm to it.
Again, sorry?
Add some rhythm.
Oh, probably we are having internet connections. I think your internet or something. Can you say it again, please?
Yes. Maybe we could add some rhythm.
Oh,
rhythm.
Okay. Well, yes. At this point, the rhythm happens because you bounce the wall. So adding rhythm would be another paradigm in the graphics. We will do that, but right now,
can we add like a sample instead of an oscillator?
Like a small hitting of a pulse of a rhythm or something. Yes, we could do that, and we will do that. But one thing that I think could work a lot, or at least will help, is what happens if we expand the range of our sounds? Because right now we only have one octave, right? So first of all, are you okay, guys? Could you turn on your cameras? Please turn on your cameras. Let me see. And then I really hope that you are starting to enjoy what will happen. I mean, this is just the beginning, okay? So I hope that you enjoy what we are doing. I really hope so. Otherwise, we are in troubles. But in addition to understand what we are doing, I want to hear something that we do like, okay? I want to feel that we are engaged and that we are doing something that could be interesting, okay? So I truly recommend you to suggest things. The rhythm is something that we will work, but not in this particular example because we are tied to the bouncing, okay? However, imagine that I want this now to be 4 octaves long. What can we do?
Increase the diatonic size of the array, like with more numbers.
Yeah, but okay, if this is a full octave, right? If this is a full octave, right? One solution would be actually to do 12, and then what would be the next? If this is 0, and then this is 12, which is the next one? Will be 14, right? And so on and so on. But that's not very nice, to be honest. How can we repeat the octave many times? We will need to use this array and multiply it many times, right? Do you have any idea? So how can we do that? This is just pure code. How can we create 3 octaves like this one, but that are increasing over time, over the duration of the array?
With another 4.
Okay.
A field array or something like that?
Oh, I don't think field array you could, but let me see something. Can we in JavaScript multiply the values of elements in array? Let's see, JavaScript multiply all elements in array. Multiply all elements in array. Do we have a way? No, it seems that we do not have elements for doing that. We need to do a for. In Super Collider, you could do that, but not in JavaScript. So yes, how many nodes do we want? Let's say that now we are going to change a couple of things here. This is diatonic, okay? But we are not going to use directly the diatonic nodes. How many nodes do we want? Well, let's say that we want, instead of having diatonic length, how many nodes do we want? Let's say that we want a range of 20 nodes, okay? We want 20 nodes, and then we are going to create a variable about nodes. These are our real or real nodes. Do you follow what I'm doing? Real nodes is going to be an array. Okay? You follow what I'm doing?
Yes.
And then here I'm going to do a for in the same way that we were doing here. So please, I'm going to borrow the for. You follow what I'm doing. But instead of this, I'm going to go through amount of nodes, okay? And then what I'm going to do here is that I'm going to do real nodes dot push. One more time, we're going to start to add values of what? Of diatonic, right? Index I, however, I is going to be increasing, so we're going to use a module over, okay, diatonic length, okay? And at the end of this, that's it. And then that's it. And then instead of using, where were we using the playing node? This node that is here, right? Now amount of nodes is being divided. And then the node is not going to be called on diatonic, but it's going to be called on real nodes, okay? Instead of calling on diatonic, we are going to be calling on real nodes. Now you can say what? Now you have to say what? Okay, okay.
What?
Okay,
What?
that's good.
Can't believe it. Oh my God.
Okay, let's start with this. Because we want to make a program that is not tied to the diatonic scale, but we want to use the diatonic scale as the skeleton. Yes, we want to use the diatonic scale as the skeleton for building many nodes. How many nodes? Now it will depend on amount of nodes. We can make a composition with 3 nodes, or we can make a composition of 50 nodes, for example, right? We will have a much broader amount of, our keyboard is a bigger keyboard, right? Well, what did you do then? Okay, first of all, we create a for loop here, okay? So what are we doing is saying, we want okay, give me 1 more second. Okay, that's it. We have a for, okay? This is straightforward, right? We have a for, and we are saying, please, we have again an array that is empty, okay? An array that is empty. And we will iterate over amount of nodes, which in this particular case is of 12, right? So we know, as in the previous example, that we are starting with an empty array. We know that I will be 0, and then 1, and then 2, and then 3, 4, 5, 6, 7, 8, 9, 12. Then we are adding elements on each iteration, okay? So we are going here, and we are saying, please go to diatonic. Okay, please give me the element that you have in diatonic I. Okay, I. Can you tell me what is this symbol?
Modulation, modulo.
Module. Yes, and what is the module?
The rest of the division.
Who is speaking?
Me, Diana.
Diana, where are you, Diana?
Here I am.
Ah, okay. Yes. Please write in the chat if you don't remember what the module operator is. It's completely valid to say, I don't remember. 1, 2, 3, 4, 5, 6, 7. Okay, that's it. Okay, that's enough. Okay. Do you remember when you were in 7 divided by 3, right? How much is this? Is 2, right? 2 times 3 is 6, right? Well, that's the way I learned to divide in the school, and probably you too. And then we have a 1 here, right? This one is the residual, okay? So if I say 7 module 3 is 1, okay? So the module is the residual of the division of between two numbers. It is very common to see it in code. Why? For example, in order to know if a number is even or odd, okay, you can use the module of 2. Why? Because if you have 9 module 2, could you tell me what is 9 module 2, Jared?
1.
No, wait, it's fine. Yeah, don't worry. Because 9 over 2, it's oh, sorry, 9 over 2 is 4, right? So 9 divided by 2 is 4. Forget about the decimal points in this way of computation. And then the residual, sorry, 9 division over 2, and 9 module 2 is 1. And how much is 10 module 2?
0.
0.
And 11 module 2?
1.
And 12 module 2?
0.
And 13 module 1?
1.
14 module 2?
And so on.
Okay, so one way for knowing if a number is even basically is if x module 2 is equal 0, right? Then blah, 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 blah. That's a nice and very short way for knowing if a number is module 2, right? Why are we using the module in this context? Why are we using the module here? Because we are imagine that you have an array, okay? Imagine that you have an array. Imagine that you have an array of 4 elements. I don't know, 9, 2, and 3. And you want to repeat over and over and over 9, 2, 3, 9, 2, 3, 9, 2, 3, 9, 2, 3, right? Well, and you have a counter, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and so on. Okay? Imagine that you have a counter that is increasing, right? So, and you know that this duration, this length is 3, is of length 3, right? And we know that this array is called A of array. So if I say A 0, what number do I get?
9.
If I say A1, what number do I get?
2.
If I say A2, what number do I get?
3.
If I say A3, what number do I get?
No.
Out of bouncing, and then I get a mistake and my program stopped working, right? However, what happens if I do 8, 0, module the length of my array. How much is 0 modulo 3? How much is 0 divided by 3?
0.
And then the residual is 0. So what is A0?
0.
No, A0 now. A?
9.
Now, how much is A? Let me go to this. Can you see here if I write here?
Yes.
So how much is A? 1 module 3. How much is 1 module 3?
2.
No. 1 divided by 3 is 0. And the residual is
23.
Is 1. So how much is A index 1?
9.
No, index 1 is this location.
Oh, 2.
2. Now we have A 2 module 3. How much is 2 module 3?
0.
No.
1.
No. 2?
3.
2 divided by 3 is 0, right? And the residual is what?
2.
It's 2, right? 0
Right.
divided by 3 is 0. And how much is the residual? 0. 1 divided by 3 is 0. And the residual is 1. Right? So we were having an array index 9. What was the other number?
2
and 3.
2 and 3.
And 3. So we were doing A0 module 3 is 9. A1 module 3 it's 2. And then we have A2 module 3 it's
0.
3, right? Yeah, and then we have A3 module 3. How much is 3 module 3?
Teacher, 2 module 3.
0.
0.
Teacher, I got lost. 2 module 3. It will be like,
wait a minute. I'm not using the value. I'm using the index of the value. So yes, 2 module 3 is 2.
no.
Yes.
It could be 0, doesn't it? Because the index 2 is 3 and 3 module 3 is 0, doesn't it?
2 module 3?
No, but we are like using the index 2 of the array, doesn't it? So 2 module 3, it will be like 3 module 3.
No, again. 2 module 3, how much is 2 module 3?
2.
And what is the value of
3?
A index 2?
So of the result, we are like, of the result of the module, we are taking that value of the index as the index of the array.
Exactly.
Okay, I got it. Thank you, teacher.
Yes. So how much is A? No, sorry. 3 module 3?
0.
3 module 3, 0. So what is the A
9.
index
9.
0?
9.
9.
9.
And then A 4 module 3. How much is 4 module 3?
2.
No, 4 module 3.
1.
1.
Divided
2.
by 3 is 1. And then we have 1 in the residual, right?
And the number is 2.
So A module 1 is
2.
2. And then A 5 module 3, what is 5 module 3?
2.
And what is A index 2?
3.
3. So as you can see, I have a counter that is going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to the infinitum and beyond, okay? However, our repetitions here are 9 to 3, 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 9 to 3. No matter the index here is increasing and increasing and increasing. You understand what I'm trying to explain? Yes?
Yes.
Are you sure?
No.
No. No.
Oh, okay. Let's do it. 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 Okay. One more time.
Maybe if we change the what we have in
the values
our
of the arrays,
like for I don't know, for colors or something like that, instead of numbers and numbers.
Okay, sounds logic. Sounds good. Or okay, I have an array that is C. My array C, it's an array that has here red, right? And then has green, and then it has blue. Does that make sense? Yes?
Yes.
So what is the length, what is the size of this array?
2, 3.
3.
How many elements do we have in the array?
3.
3. So C dot length, it's equal to 3, right? So if we, and then we have a counter. So we say C of 0 module C dot length, okay? So how much is C dot length? We know it's 3. So how much is, what is the residual of 0 divided by 3?
0.
0, right? So what is C index 0?
Red.
So what do we get here? Red. Now C 1 module C dot length. How much is C dot length?
3.
So what is the residual of 1 divided by 3?
1.
So what is the index of C index 1?
Green.
Green.
So we get a green, right? So how much is C 2 module C dot length? What is C dot length? What is the size of the array? 3. So
3.
what is 2 module 3?
2.
0.
No, 2 module
2.
It's 2. Who says 0?
I got confused. Sorry.
Okay. What is, it's 2, right?
So it would be blue.
Yes.
So what is C index 2?
Blue.
Blue, right? The nice thing happens now here. If we have a 3, what is the residual of 3 module C dot length?
0.
What is the value of C index 0?
Red.
Red.
And then we have C, and then we have what is 4 module 3?
1.
What is the index of C1?
Green.
Green. What is going to happen here?
It will repeat like that pattern of colors.
We will be red, green, blue, 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 using a counter that is going to the infinitum, right? With this second explanation, anybody within a question, I can be here until 5 a.m. until you get it. But I need to be sure that everybody here got the idea about the use of a module in an order to create a repetition.
Yes.
Are you sure?
Okay.
Don't be
Crystal
shy.
clear.
Yes.
You can, yes? Does that make sense?
Yes.
Okay, so we will use this, and then this is a repetition, right? Yes?
Yes.
Yes.
However, I don't want to do 0, 2, 4, 5, 7, 9, 12, 12. 0, 2, 4, 5, 7, 9, 11, 12. Because I want to increase the second time, I mean, what I want at the end to have in my real notes, what I want to have in my real notes, what I do want to have in my real notes is if I have in my amount of note, I have 24 notes, right? What I do want, and I think with that we are going to end up the class, is 0, 2, 4, 5, 7, 9, 11, and then I want to have 12, 14, 16, 17, 19, 21. Oh, what is this? 21 and
23.
23. And then if I keep going, I want to have 24, 26, and so on. Do you see what I'm doing?
Yes.
How can I do this mathematically based on the thing that we were doing here? Now we are repeating here. Tuk, 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 tuk. But the next time, I want to keep going now, adding 12. Right? Plus 12. And the third time, plus 24. And the next time, plus 36. How can we do this?
With an if?
Yeah, but that...
With a 4 inside an if? No. With an if inside a 4?
No, we can take advantage more about the pure mathematics than the ifs, because the ifs will have the limitation at some point. So first of all, I'm gonna remove this to be of 1, 2, 3, 4, 5, 6, and 7 nodes, right? I want you to see this. The next time, this should be, what is happening here? This is 12. This is 14. This is, what am I doing here? The 16. And then
you're adding 12, right?
Exactly. What I want to use 12, this is 19. This is 21. And this is 23, right?
Right.
So basically on each repetition, I'm adding 12. I'm adding 12, right? So what can I do in order to do this?
I equal
Plus
plus 12.
Oh, okay. So we are pushing the value that is here, right? Multiply. We are going to multiply this, right? Times 12, right? Does that make sense?
Actually don't.
This is getting tricky. Okay, it's 2143. Let me see something. Okay. Okay, because here we have a lot of problems. We have English problem, math problem, and code problem all together, and 10 p.m. problem. So we have many problems. I don't want to do it without you understanding what I'm doing. We are getting there. We are getting there. Just be patient. But I'm a little bit worried because it's 9:43. Let's talk about your assignment for next class. Your next assignment will be graded. Your next assignment will be your grade for the first partial, okay? But this is pretty simple, okay? You have to modify this code in such a way, right? In such a way that we have, okay, the full set of 5 octaves here. So basically, I want you to solve this section here, okay? Does that make sense? But I will give you, we will have 10 minutes for giving a hint, okay? Emerson, yes. No lloren por mí. Okay, let me see. Maybe Emerson is right, and that's not fair. How can I do? Okay, let's put it in a fancy way. Let's do this. Modify this code in such a way that it sounds nicer. Okay, as simple as that. Because this is also a process of art. Pardon me? Modify this code in such a way that becomes more personal. I mean, let me say something. With this pandemic situation, without being together all the time, having one class per week and so on, I'm trying to be very empathic with you. I just want you to enjoy the assignment, okay? I just want you to do something that is nice. Modify this code in such a way that has something that you create. Maybe you go and then you decide that instead of being circles, they become squares. Fine. Make that instead of going in a random movement, they all move together in a sequential order. That's fine. Make it that when they collide, when they go together and they bounce together, they move very hard, by the way. If you can see the code that we have right now, they just pass over. Do you understand what I'm saying? The balls, they just pass over. If you feel that you can do collisions, so that means when they touch each other, they move, that's fine. Also, if you decide that you want to change the sounds to become a sampler, instead of a synthesis thing, you make it a sampler, a small percussion, that's fine. That is related with the first assignment. Do you remember that I sent you a tutorial where a sound was being played? If you want this to be played, that's fine, okay? So I'm very open to this assignment. We still have time for doing something more rigid in terms of the exam. I just want you to do something different for this code. Please modify this code, okay? And I will be able to know if you modify the code and then you say, okay, I'm going to modify the code. So instead of doing this, I say rect, and then you do this, okay? And then you go to rect, okay? And then you see rect, okay? Let me, oh, we have a problem here. Okay, no, I think this is going to work. Okay, this is my first assignment. I'm done. I'm going to play Minecraft, okay? Well, I will know for sure that this is a very simple situation, okay? I will understand it. And I mean, I have experience knowing that type of things, okay? But if you, for example, make something like here, okay? Here sounds pianos. If it here sounds pianos, piano samplers, okay? And then here I have drums, okay? And here I have sinusoidals, okay? And here I have the saws. Okay, that sounds a little bit more nice, okay? This is nicer. For example, if you have two different kind of shapes, some of them are squares. Some of them are squares. Some of them are rectangles, okay? And when the circle hits, you sound one kind of sound. And the rectangle hits, it sounds in a different way. That's also interesting. Another option, some of them, this is more like, okay, some of them only move left to right, and some of them only move top to bottom, okay? The ones that move left to right produce one sound. The one that moves top to bottom produces another sound. That means that by random, at the very beginning, some of them will have a speed of x0. And if they have a speed of x0, then they do have a speed of y, or the other way around. If they do have a speed of y0, then they do have a speed of x with a different value. Some of you were asking if you could have something that is rhythmic. Yes, there is one way for having rhythmic patterns. That would be that the speed, the thing that we have here, okay? As you can see here, the speed that we are creating here, okay? This speed has a random number. But if you decide that instead of having a few set of random numbers, you only have options, speed 1 or speed 2 or speed 3 or speed 4, then you are going to automatically start to generate rhythms. Do you understand why? At this point in the code, the 10 objects are moving by random speeds, right? By random speeds. However, if you say no, they can be either speed 1 or speed 2 or speed 3. So automatically they are going to start to move in some kind of synchronization. You understand that? Are you no? Yes? Diana, understand what I'm saying? I think David is saying, Emerson is also saying. If instead of having random numbers with floating points, you have something like possible variables, possible speeds are equal, again, to an array. They can move either at 1 or 2 or 3 or 4 or 5, right? And these are the possible speeds. You will have a very nice rhythmic sequencer, okay? But be careful, because now how are you going to choose here a random speed, right? That is something that could happen. For example, just by now, instead of this, because we are having 9 minutes. If, for example, instead of having random numbers, I said that the x, the speed of the y for now, by the way, okay? I'm commenting this and I'm saying the speed of y, it's equals dot push 0, right? And then here in the push of x, okay, in the push of x, I select a random number, and this random number become an integer, okay? An integer. What is gonna happen here? Just by curiosity. Now, okay, they are just moving, okay, in horizontal movements, and they have a specific rhythm, okay, because they can only be 0 or 1 or 2 or 3, right? And if I decide that the speed is going from high pitch to lower pitch, you are only going to have tu 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 tu, and the rhythm is going to be repetitive, okay? So what I want you to be trained is that with very simple modifications in the code, you are going to start to have very different sonic experiences, okay? You don't have to suffer. Suffer is optional. In this life, suffering is optional. So the assignment is for you to enjoy the way of doing a nice sonic experience based on this code. Okay? And probably you may want to solve this situation that is happening here. Be very careful. It is solved with pure models and pure multiplications, okay? Just modules and multiplications. You don't need an if and so on. You just need to sit and with a piece of paper, do what we've been doing on the screen. How can you increase over 12 each time that your value is increasing on values of sevens, right? Each time that you have more values than between, how many notes do we have here? We have 1, 2, 3, 4, 5, 6, 7, right? So if your index module, basically here, I'm going to put a hint here, right? I'm going to put here index, the module, no, the counter index of size of a scale multiply times 12, okay? That's the solution, okay? Or something like that, okay? This hint will solve what we didn't finish today. This hint is giving you ideas about how to move the balls. This hint is giving you ideas about how to modify the graphics, okay? I'm playing with that. I want to hear nice things. Okay, questions?
Yeah, I have a question. In order to add some kind of image and all that kind of thing, do we have to do first the graphics on the other page, on the page like the normal page?
Oh, on the open processing?
Exactly, the open processing page. Or can we do it everything here in the glitch?
Oh, you can do everything in the glitch. The nice thing of this one is that you can see the graphics. I mean, it depends of the variations that you do. I do recommend you that you focus more on the sound than on the graphics, okay? So it's up to you. How do you feel more comfortable, okay? So,
okay.
Tomorrow morning, or actually tomorrow midnight, not morning, but midnight, because I have a meeting early morning, I will write the more defining description about the assignment. But the essence of the assignment is enjoy the musical experience that you will create based on this code. Okay? As simple as that. As simple as that. If you are in drum syncs, well, try to do a synchronization thing. If you are in textures, try to do textures. If you want to add some samplers and you manage to do the assignment of the web tutorial that I send you the first and in the second week, and you have that working and you know how to play an audio file, you can try to play an audio file in some context, okay? Again, focus more in the sound than in the graphics, okay? And that's it. That's it for today. Well, we have 3 more minutes, so I don't know if you have any question.
No, teacher.
No? Are you sure? And again, it's gonna be fine. It's nice. Yeah, look how simple it was to change something. And in this particular case, okay, in this particular case, I'm gonna increase this, well, because we still have the problem of the pitch to solve.
Professor, when are
Yes.
your tutoring sessions?
Pardon me?
When are your tutoring sessions?
Oh, for example, Monday morning is a good time for me. Monday mornings, okay? Monday 10 a.m. is the time that I saw some of you guys the other day, and we can do that without any problem.
I had class on Monday from 10
another
to
day?
11:30.
Yes, let me stop this. We can have it. We can. Let me open this. Give me just 1 second. Can you still see my window? No, maybe not. Maybe yes. I don't know.
Yes, you can see it.
The new one?
We see the browser.
The new browser.
Browser.
Yeah, but I mean the.
No, we see the P5.js.
Oh, the calendar. For example, yeah, I think I can Monday from 10 to 4, Tuesday from 10 to 1, Wednesday from...
We are seeing the P5.js.
Oh, I see. Let me stop this. Let me share this. Let me open desktop. That's it. You can choose, guys. You can choose.
Can you zoom in a little bit more, please?
Mm-hmm. For me, it's good. This moment is good. Okay. Monday, this moment is good. This actually, let me turn off this because this is not mine. Okay. Take a snapshot, or I can take you a snapshot and then you just send me your email. Send me an email about the time. You don't have to decide right now. Okay, I'm gonna share you that. I'm gonna share you my calendar and then you can send me a possible time. Is that okay?
Yes, thank you, teacher.
Okay.
Thank you, teacher.
Well, I hope you enjoyed the class. I think we did a lot of progress. Again, the beginning is tough. The beginning about removing all the rusty things about coding can be a little bit tiring, but sooner than later, we are gonna get into more interesting sound situations, okay? Just be patient and enjoy this because at the end, the results could be very, very attractive, okay?
Okay, teacher, thanks.
Excellent.
Thank you, teacher.
Have a good night then.
Thanks, teacher.
Thank you, teacher. Good
Thank
night.
you. Bye-bye. Have a nice
Thank you,
weekend.
teacher. See ya.
Have a nice
Thank you,
week.
teacher.
See you.
Bye. Have a
Thank you,
nice
teacher.
weekend.
Bye-bye.
Thank you, teacher.
Enjoy.
I just have a question about the last part, the last code, the last line you just added.
Yes.
The real nodes dot push, the diatonic I module diatonic dot length.
That is just that. Do you remember that we were describing about the module and how can we use the module in order to get a repetition of the elements? So, David, are you there? David? David?
Ya regresé, profe. Perdón, creo que se me fue el internet.
It's okay. So do you remember that we were talking about how can we use the module in order to repeat and repeat and repeat the elements of an array?
Yes, yes.
Well,
like
that's what we are doing here. Do you remember the example about 923, 923 using the module? This is exactly what we are doing there. This is the size of the array. Oh, I'm not sharing the screen. But is that your question?
Yes, that's my question. I have your code, so I see when you highlight the.
Oh, I see. So it is exactly here, right? This is the size of the array. This is the increasing number because it's the module we are repeating and repeating. So basically it's a way for saying 0, 2, 4, 5, 7, 9, 11, 0, 2, 4, 5, 7, 9, 11, 0, 4, 0, 2, 4. That's a way for repeating.
Okay.
I
think it's more clear. So it's a way that we doesn't have to. We doesn't get those numbers exactly like the 0, 2, 4, 5, 7, but it's something that it iterates in the same numbers.
It's a way for repeating and repeating this array.
Okay.
If you go to the recording of this class, in all the section where we are talking about the example about the 9 to 3, do you remember? And we were saying C it's equal red, blue, red, green, and blue, red, green, and blue.
Yes.
This is the size of the array. This is the counter. This is the module. And then this is the IC. So this line is actually a way for getting an array and start to repeat in the example that we did in class, red, green, and blue, red, green, and blue, red, green, and blue, red, and green, for example. How many times? Well, that will depend of the amount of nodes, right? In this particular case, where the amount of nodes is 24, right? And our diatonic scale is 0, 2, 4, 5, 7, 9, 11. This is a way for having an array that says 0, 2, 4, 5, 7, 9, 11. So we have 7 there. And then again, 0, 2, 4, 5, 7, 9, 11. And then again, 0, 2, 4, 5, 7, 9, 11. Right?
Okay. Yeah.
Are you sure that you're understanding? I mean, are you sure about that?
Yes. With the example of the colors, I think I got it once more clear.
This one is the example of the colors. This line, the line 30, well, from 38 to 41 is the example of the colors. But now in the context of our specific array, instead of colors, we have the diatonic numbers, right? Basically that, instead of that.
Okay. Yeah, perfect.
Excellent.
Thank you, teacher.
Well, then see you soon.
See you, teacher.
Have a good night.
Good night.
Bye.